Thanks so much.
Good morning, and to the colleagues in the room and online, thank you, Anna Paula. So this morning, we're going to present Monitor Earth Observation Monitorio tool that has been jointly developed with Vivian and with Anna Paula, with Antonio Scognamillo. And essentially, we've been testing Earth observation data analysis on, let's say, before the project intervention and after the project intervention, over a large database, a global database of project boundaries. So this is a global database of nature-based carbon offsetting projects published by Karmic et al. So we've been using that as a large test bed for us to understand how far can Earth observation help, depending on project characteristics, which indicators are more likely to show some trends, and what they could possibly mean for monitoring frameworks. So Monitoreo is the answer to these questions of what it takes to do restoration monitoring at large scales. And I'm glad that Vivian has joined me right now. So we know that the restoration sites are not randomized. So practitioners, they choose them, often the most degraded areas, often the most accessible, often where political will exists. So this means a simple before and after comparison will always overestimate impact, because the site was likely on a recovery trajectory anyway, or understated because it started from a worse baseline. So we use a difference in difference approach on Earth observation time series. We build a 3 years pre-intervention baseline. Then we track both the restoration site and a matched control area through 2024. Control areas are selected in 3 ways. We have a 2-kilometer spatial buffer, a random areas with high land cover similarity using cosine distance on MODIS data, and then expert-defined controls where we have ecological knowledge. Then we apply man-candle trend test in its Hamdraw autocorrelation corrected form so that it handles the temporal dependency in monthly Earth observation composites that standard tests don't. And then for Mexico, this is work in progress led by Ana Paula, where we are advancing to synthetic control methods, which reconstruct the counterfactual without requiring parallel trends. We have 600 donor circles for each site. We apply Manalobis matching on topography and climate, and results are promising. Significance is emerging. So one of the clearest findings from this work is that NDVI alone is not enough, and in some cases it actively misleads. So the core stack of the Monitoreo is 3 MODIS-derived indicators: NDVI for greenness, NDWI for moisture, and land surface temperature. Each captures a different dimension of ecosystem state. The combination reveals things that single indicator monitoring misses entirely, and I will show you the most important example in the next slide. For the GreenMex application in Mexico, we added now the full vapor stack. So actual evapotranspiration, net primary productivity, and water use efficiency. And we know that water use efficiency, in particular, NPP divided by ET, is the right metric for dryland bioforest corridors, where the policy objective is not just greenness, but resilient water use. We also added landscape connectivity, and then we use principal component and delta and principal component framework, which directly tracks whether forest patches are becoming better connected across the landscape. And then we have RAOSCU spectral diversity as a biodiversity proxy, all within the same difference in difference framework. So the link between Earth observation and causal inference is not automatic from what we have experienced in this large test bed. Earth observation gives you wall-to-wall coverage and 20 years of history. Impact evaluation gives you the counterfactual logic. And of course, we need both, and we need to design their integration before the project starts in an ideal world and not after. So the Monitoreo tools extracts the time series simultaneously for the intervention and the control areas, and then it computes monthly composites aligned with each project start date, and runs the difference and difference at the aggregator spatial mean level, which preserves comparability while enabling inference. The open question I'd put to this room is the household link. So Earth observation captures biophysical outcomes, Socioeconomic outcomes, income, food security, labor reallocation, they require survey data linked to the same site. So matching GPS plot boundaries from surveys to Earth observation pixels is the critical unresolved integration step. How small a plot can you meaningfully monitor with Earth observation data? And that threshold matters enormously for the communities doing the actual, restoration work. This is the interface that we have built, which allows to, in real time, test the various indicators, compare with the intervention areas and the control areas, and extract relevant statistics and charts. And now it's being customized for Mexico. So we have two versions: one with the test bed, with almost 330 project sites all over the world. As we will see, I will provide some statistics. And instead, this is the one being now used within the Green Mex to carry out the monitoring evaluation. So from our 320 test bed, we see that 62% of the 320 projects globally show statistically significant ecological trends in at least one indicator. But the number that matters most for evaluation design is this one. So project monitored for more than 10 years show significant results 49% of the time. Projects monitored for less than 5 years, 15%. This is not a methodological finding, it's rather a funding architecture finding, meaning that 3-year project cycles are fundamentally misaligned with ecosystem recovery timescales. The dataset spans 67.4 million hectares of restored land across 55 countries. We have Latin America, which dominates 207 projects, followed by North America, Africa, and Asia. The geographic insight is that the scale of monitoring must adapt to context. For instance, African projects, they average 4,600 hectares, so they're large landscape scale intervention. North American projects average under 1,400 hectares, so small, fragmented, which actually shows higher detection rates because management is more focused. A 250 meters MODIS pixel, and that is 1% of a 2 million hectare project, is not the same monitoring challenge as one that covers 10% of a 100 hectare plot. This is the map of the project size that we've been using to develop the monitor area and to test the various indicators. So this is probably the finding that most surprised us. And it's the strongest argument for multi-indicator monitoring. So 44 projects globally showed NDVI increasing, while NDWI decreased simultaneously. So if we only look at NDVI, we call that a success. No, we have more vegetation. But if we add NDWI, then we are looking at the eco-hydrological trade-off. So afforestation or woody encroachment increases transpiration, which draws down surface moisture signal. So the vegetation is greener, but the landscape is drier. The convergence case instead, where we have NDVI increasing and land surface temperature decreasing together, that is 20 projects, mostly in Africa and Asia, and that is the strongest signature we have of genuine ecosystem recovery, because we see both indicators going in the right path, the right theoretical path associated with ecosystem restoration. So we have the vegetation is growing and the land is cooling, basically, in this case. This distinction matters for carbon markets, for water resource planning, and for the communities depending on this landscape. So we believe that single indicator reporting cannot really capture these dynamics. This is the temporal curve, which is unambiguous. So under 5 years of monitoring, 15% of projects show significant trends. Over 10 years, we have 49%. The Kendall-Tau correlation with monitoring duration is at 0.28, with a p less than 0.001, so it's significant. So this is really meaning that we have a structural misalignment between how the ecosystem recovery actually works, so the roots maturing, hydrological shifting, soil carbon accumulation, and how the international funding cycles are structured. So 3 to 5 years projects simply cannot detect what they're trying to measure. The signal is real, but it hasn't had time to emerge, essentially. So we need more time. The implication for impact evaluation design is concrete. If we are evaluating a restoration project that is less than 5 years old, we have to calibrate the expectations accordingly. And we have to be also, as transparent and honest as possible with the founders about what Earth observation can confirm and cannot confirm at that stage, essentially. 3 minutes, yes. One slide left. So a known and important limitation is the spatial resolution. So MODIS at 250 meters to 1 kilometer is the right scale for large landscape level projects, but for small projects, so under 1,000 hectares, and especially for Africa's smallholder plots averaging half a hectare to 2 hectares, a MODIS pixel may cover an entire farm plus its neighbors. So small projects actually show higher NDVI detection rates. We have 54% versus 35% for large projects. And our hypothesis is that small projects benefit from more focused intensive management and reduced ecological complexity. But the resolution artifacts is also real. So we validated anomalous small site results against Landsat 30 meters. And in several cases, what looked like a false positive in MODIS was confirmed as genuine change in final resolution. So the practical implication here is that for projects under 100 hectares, MODIS alone is not sufficient. Sentinel at 10 meters is the right instrument. And that is what exactly we want to use in Estella for agricultural monitoring. Estella is this new project that Anna Paula just mentioned. And so the takeaway message is really threefold. So first, result-based finance should reevaluate its monitoring and evaluation framework. So accountability mechanism that require 3 years project reporting cycles cannot capture the restoration impact using Earth observation data. Multi-indicator monitoring is advised over a minimum of 10 years. And this is not really a methodological preference, it's more of a scientific requirement. Second, align the monitoring and evaluation with ecology. So ecosystems don't recover on a 3 years project cycle. So institutional funding should mandate and resource post-intervention Earth observation monitoring for a minimum of a decade. Third and last, Earth observation is a complement, not a replacement. So the satellites, they track biophysical dynamics cost effectively, but they cannot prove a farmer's income increased, cannot capture tenure security, cannot replace the household survey. So the frontier is seamlessly marrying Earth observation pixel data with socioeconomic survey plots. And that is the conversation I hope that this session will open. So Monitorio provides the baseline. We invite the impact evaluation community to help us build the causal inference layer, let's say, on top of this. So thank you. Thank you very much.
Okay, great. Thanks so much. I think one thing that we could say about Monitoreo is also an effort to create also a framework for analyzing land restoration. So I think it's, as Lorenzo was saying, it was important not to only look at NDVI and also try to populate that platform that we're building with other projects, because that can shed light not only on one particular project, but the bulk of projects that are being put in place for land restoration. And this work is reflected in one of the chapters as well, we forgot to say, of the geospatial impact evaluation in practice, together with some other work that we've done with ESP, with Nick and other colleagues, El Savali, on restoration. Okay, well, thanks. We have maybe time for a couple of minutes from the audience on this particular presentation. Any questions?
Yeah, thanks so much for the presentation. Can you say something in general about the types of interventions that are covered? And second, have you stratified the results by intervention type?
Much. So the majority of the intervention were reforestation and afforestation. And we stratified by intervention times. We realized that essentially the timeline slide shows that Projects that have a monitoring period less than 5 years, essentially, we only had 15% of those ones who had significant trends. Whereas projects where we had 10 years of monitoring because they started earlier, we had 49%. And then we have also more interesting findings where we combine the different stratification. So I invite you to consult we have a working paper which is going to be published where we've really dissecting the various strata. It would be too complex to put it on the slides, but definitely we show the implication of size and timing depending on the region, for instance. And I think if I remember well, we also had other stratification based on if I remember well, on other consideration on the relationship between NDVI, land surface temperature, and normalize the moisture. So how these change depending also where we are located in the 3 regions. Thank you.
Okay, thanks. Yeah, I was thinking, for example, deforestation coupled with burning would have a much different profile, especially in the short term, than without burning, for example.
Yeah.
Thanks so much. Any other questions? Okay, so perhaps we can pass to the next presentation.
No, so
Can we have the second presentation, please? Yeah.
Thank you, Ana Paola, and good morning, everyone. My name is Andrea Amparore. I am the data manager in the Office of Emergencies and Resilience of FAO. So in the next few minutes, I will describe our ongoing efforts in, let's say, transitioning from simple flood detection to a deeper, we call it like flood intelligence. So it's a slightly different topic from if compared with other presentations, but also with Ana Paula, we recently discussed about potential linkages and let's say areas of cross-pollination. Before we jump into the topic, just a few words on the context. I work in a program called Data in Emergencies, known as DEM, and what we do is to collect and analyze data in order to better understand how crises affect agriculture and agricultural livelihoods, and we include both natural and man-made crises. How we do that? But we have different means, different channels, different pillars. Probably the core of our activity is household monitoring system that is operational in a quite large number of countries. But we also perform rapid impact assessments after major disasters. We run geospatial and EO analysis, and we develop and maintain operational decision support tools for humanitarian response. Our ultimate goal is really to provide FAO and all our partners with timely evidence to support decision-making in emergency response, but not only, also anticipatory action and recovery planning. We have an open geospatial hub, dataenemergencies.fao.org, where we publish all our data sets, let's say publicly for the common good, and also our findings and reports. So you are invited to discover this hub. So among the geospatial responsibility of DEM, already a couple of years ago, we developed a platform called EVE, Events Visualization in Emergencies, that aims at detecting and monitoring floods on a global extent to estimate potential impact on agriculture and livelihoods. It is based on VIIR's NOAA daily data sets. Why we have chosen for VIIR's? Because it probably provides, from our perspective, a good good enough balance between resolution that is compatible with our effort of going global. Then, of course, time resolution, there is a new image every day. And then, of course, also extent, which is near global. It comes also with its own limitation that are mainly linked with the fact that it's an optical data set. So it's really limited by cloud presence. It's a bit mitigated by the near infrared and the infrared bands. But yeah, so we have developed that platform a couple of years ago. It's already operational, adopted in 40 countries. It provides statistics at subnational level down to admin 2 level on the potential impact of detected floods on agricultural livelihoods, mainly using public open source and FAO datasets on vulnerability and exposure. But there are a number of limitations, or at least areas that we would like to improve. We are working on a second version of this platform, and probably the major enhancements that we are gonna, let's say, apply to the system is the topic of today's presentation. So we all know that floods can have a major humanitarian impact on agriculture and on population, but it's not always the case. Floods may be recurrent, may be seasonal. Some cases, they also may be beneficial for agriculture. In other cases, they're even artificial. There are a lot of irrigation practices that consist in flooding large areas. So we really want to, at the moment, the system is capable of telling us where water is and when, but we really want to understand more. We want to know for each pixel whether this flood is expected or not, very simply put. Yeah, so this is a simple couple of examples about this type of phenomena. So these are two the satellite-derived data sets from VIIRS covering Mopti in Mali on your left, Mopti province, and then Suphanburi province in, no, sorry, this is Mopti on the left, and then Unity province in South Sudan. We see that there's a lot of water, there's no doubt about that. The detection question is answered, so there is a lot of water, but then the operational question is not answered. So is this water normal for this place and moment of the year? Is it something that we should escalate or investigate further? Just looking at a satellite image of a given date, that's not, I mean, that's not enough for us. And that's why we are working on an initiative that we called VISTA, VIIRS Surface Water Temporal Atlas, and we want to process the daily VIIRS observations since the beginning of the VIIRS program in January 2012. So it's soon going to be 15 years. So it's about processing more than 5,000 daily global satellite images on 375-meter resolution. Our goal is to develop a decadal, therefore a 10 days period calendar of flood probability, likelihood of experiencing flood. So it's going to be an information both georeference and time enabled. We are working on that. Processing is currently ongoing. It takes weeks. We haven't published anything for the moment, but after the summer, we really plan to publish the data set. And of course, the code base, we are working on a paper. This initiative is coordinated by us in FAO and the Joint Research Center of the European Commission, but there is like an active participation of a number of actors from NOAA, of course, the Dartmouth Flood Observatory, Hacken University, Columbia Climate School, and WFP. And Google also participated with in-kind support, allowing us to benefit from virtually unlimited computational power and storing capacity. So we really expect to release the data set after the summer. Okay, in order to respect the 10 minutes boundary that we agreed beforehand, wow, 3 minutes left. I got around. So in a nutshell, you see the Vista part of the slide. I'm going to skip that one. You got the concept. Our goal is really to provide a pixel level water occurrence probability for each 10-day period of the year in order to better understand the seasonal occurrence, the interannual variability, and the flood persistence. Then I take off my Vista hat and I will put my Eve hat very quickly to show that we're building a system that monitor constantly on a daily basis floods, and it will use Vista to apply a kind of anomaly classification at the pixel level to extract the anomaly, to extract, let's say, the exceptional flooding and to overlay that with other type of vulnerability and exposure information, and to basically to disseminate this data publicly. I'm gonna skip it. Let's go and let's have a look at this simple example of Suphanburi province in Thailand. This is the flood extent taken from an image taken on late October 25. We see there's a lot of water. Is that a real flood? We can't really say just by watching this data set. We really need the seasonal context, the baseline, and that's where we use Vista. This is the preview of Vista dataset for this province. We really need to stop at the right decade of the observation, third decade of October, here it is. And we see that pixels range from 0, always dry in the last 15 years, to 13, meaning almost always wet in the last 15 years. And we are excluding permanent waters here. So as an user, you would probably set a threshold to extract the pixels that are expected to be wet in the third decade of October based on the last 15 years of observations. Then you go back to the observed image, you apply on top of this the filter of expected floods, and you will see that in this case, the 96–97% of the pixels that are flooded are expected to be flooded. So this is basically a huge area, huge rice fields that are irrigated in this time of the year. So we don't really have to escalate that. Opposite example, image taken in January 26th, last week of January, in Sofala province near Beira. There's a lot of water again. Let's have a look what Vista tells us for this decade of the year. We are approaching to the wet season, the third decade of January. Here it is. So there's a lot of water. Sorry, there's a lot of areas, large areas that are expected to be wet. But we also know that major floods occur during the wet season. They occur during the cyclone season where some areas are supposed to be wet anyway. So again, let's apply our usual threshold of basically more than 25% of the time being underwater. We look at the image, we overlay the mask, and we see that, let's say, more than 50% of the area that is currently flooded is let's say, an exceptional flood. So it's probably worth to further investigate and prioritize. Okay, colors here are not really visible, but we just seen the two extreme cases of expected flood, not even a flood, it's a rice paddies area, or an exceptional flood, but all the nuances in the middle, you can imagine that the spectrum is really diverse. We can investigate floods that are occurring earlier than normal, or floods that are persisting longer than expected. Very last slide. Eve 2.0 will make operational and automated what I've just shown in the last 2-3 slides by comparing the incoming near real-time observation with a Vista reference and overlay on top of this exposure layers. We're going to launch both. We're going to publish a Vista dataset after the summer and Eve 2.0 system leveraging this potential immediately after. But if you're interested in both the datasets and the platform, you can scan this QR code and you will be contacted by our team that will give you early access to both the datasets and the system, so that you can also help us improving the project and provide your feedback. That's it. Thank you.
Great presentation. I think it's going to help us a lot in many projects where we're dealing with flooding as well. Any questions for Andrea at this moment? Yes, please. Thank you. Can you perhaps use the mic? Thanks.
Great if you could speak a little bit about how you envision the data to be used by policymakers, and to maybe the missing piece, we've been talking a lot about in the context of impact evaluation, how Earth observations are complementary to ground data, survey data, the process of triangulating these kinds of very scalable monitoring, data, and how to connect that with actually what the kinds of events that farmers care about and understanding what kinds of actionable advice can come out of this kind of monitoring data. That would be great.
Thank you. That's a big question. Not sure I have the 20 minutes to answer it. Yeah, you're right. Sometimes just releasing the data set, especially if a quite complex data cube as Vista may not be enough. We're also thinking about a dedicated platform that will facilitate the life of decision makers that may not be purely geospatial technicians. Because actually, as you have seen from the example, we applied a kind of arbitrary threshold at some point to define what is expected versus what is exceptional, right? And this threshold could be defined as an arbitrary threshold because actually you don't really know. I mean, there is not a value after which you can universally agree on what is expected and what is not. In a specific country, in a specific context, just one flood every 15 years is enough to consider an as as subject to floods. In other contexts may not be the case. So in the context of this wider topic of impact evaluation, I think it's also important to consider the potential impact of external events that may influence the outcome of an intervention, right? And shocks like floods could be one of those external factors that are providing compounding effects. And system like Eve on top of Vista can help you monitor at scale, at subnational level, at the pixel level, this type of events, but also giving you, let's say, a gradient of how bad an event was compared with a baseline. That's it.
Okay, thanks so much, Andrea. Let's now move to the third presentation so that we keep the time. This is going to be about Benin.
Hello. Yeah. Good morning, afternoon, and good morning. Sorry. Thank you so much for the invitation. I mean, this is an ongoing work that we have with Ana Paula, Nicolas Sitko, and Katia Covarrubias, and also in collaboration with the OED division. I don't know that. Oh, wait, there was a typo there. Okay. That I mean, just the idea of here now is mostly to give you like a case study. So we had a nice presentation before, and now we're gonna go towards having like a case study, and this is like an ongoing progress work. So the idea is gonna be to present the geospatial impact evaluation strategy. Your feedback and comments are more than welcome. No. So just to give you an idea about this is the OGRI project. It's a global climate fund project that seeks to enhance resilience to climate change and climatic shocks. And the project decided to choose this area because it's very prone to vulnerable extreme weather events. Just to give you an idea about what is the kind of intervention that we're going to be doing, it's mostly about the construction of waterworks or water infrastructure. And also the second part, or second big component, is the construction of farming first schools. No, this is mostly what we're going to try to do. And this is the location of the map of the country, and we have the type of infrastructure that we are going to be implementing in the 5 communes of the Oueme River. So I'm going to start first with the geospatial impact evaluation, just a brochure of the project. So as I said, I mean, probably the colors here don't help me a lot, but I'm going to try to go through this part. So the first part is about the waterworks, a tree planting geospatial impact evaluation that we want to do. So this is, you can see at the top that we talk about the feasibility study that we're implementing in 2025. And then the idea is to have the project start interventions in 2026. No? So the idea of these particular interventions are to prevent floods and erosion and expand the irrigation areas. Also, there is the project to construct micro dams and the rehabilitation of other kind of dams. In terms of tree planting, the idea is just to estrange the river banks and degrade the lands. So this is mostly what we have. once we know a better idea about the exact areas in which these projects are going to be implemented, we are going to start to advance more on the evaluation, no? And the second component that I say is the Farm and First School that you can see probably in 2025 and 2026. So there was a first round that was implemented in 2025. So there are two types of Farm and First School that we are planning to, that were already rolled out. So was the Farm and First School a mix in which 50% of the members are women? And there is another component in which we are going to be complementing the Farm and First School with the Village Saving Loans Association. This is VSLA that you can see there. And there is another component, other kind of Farm and First School that is mainly for women members, no? So in terms, this is going to be in 2025, and there is going to be scale up in 2026. So basically, it's the same structure, no? So the idea of this methodology, the Farming First School, that is a methodology implemented by FAO, is just to create some schools in which farmers are going to receive training in better agricultural, climate resilient agricultural practices, also better methods in terms of agroforestry and sustainable land management. And from the Farming First School, there is going to be like an extension of that, in which the project is going to create what we call the Farming Business School. So we are going to choose among the best performing Farming First School Farming First School that are going to receive extra or additional training in terms of business plan, for example, marketing, financial management. There's going to be like a second part of the project. So I'm going to start now with the first part that I mentioned, is the waterworks and tree planting. That is more like what we plan to do now. So this is like the research question that we have that are related with the theory of change. It's mostly about if these infrastructure and land restoration interventions can increase the climate resilience in these particular areas of the Oueme Basin. And there are also, we expect to have results in the long and the middle and the long term. So the idea is mostly to have, in a more detail, is just to see if there is a reduction in terms of the frequency of floods. So probably the product that's Andrea presented is going to be very useful for us. Yeah, there are other part of things in terms of this intervention, increase tree planting, the tree density, tree coverage, and the health of vegetation indices, vegetation density, sorry. And also maybe there is a potential to see increases in agricultural yields that probably we're going to use NDVI or the kind of indicator that we have been seeing here. So in terms of the evaluation strategy and methods, the idea is there are different types of infrastructures in terms of construction of dams, irrigation perimeter, and lowland developments. But always, we were discussing during these days, is always the challenge of identifying a robust and valid counterfactual, no? So for that, we are going to rely on mostly on quasi-experimental methods. That's what the plan what we have. Maybe we're going to try to explore it. There is another way of using, for example, machine learning models to identify this area, the counterfactual areas. And also there is the fact that the farmers can have different levels of exposure to this intervention, no? To the waterworks, no? Yeah, so another part that we have is to discuss about the level of analysis, the unit of observation at which we are going to be doing this study. We thought that maybe one option is to use village, the centroids of the village in the case of Benin, and then calculate the different indicators at this level of aggregation, or maybe trying to go a little bit more detail and try to identify counterfactual areas at the pixel level, for example, or patches. In terms of the indicator that we want to use before, during, and after the intervention, we have some of the ones that we probably would have to use Andrea's indicator here. In terms of flooding and flood risk, we have soil moisture. We also thought that we could construct some flood maps using Sentinel-1. Also for the tree density, hail, and vegetation indices, we have this kind of battery of indicators, and probably I will have to add some of them that were mentioned during the presentation during these days. And in terms of yield, we're planning to use NDVI as a proxy of yields and to capture the greenness of the particular areas, or the SIF, for example. In terms of the strategy that we have, this is like we will be glad to receive any kind of feedback that you can have. So one option is to use the spatial regression discontinuity design, or spatial RDD. So in the idea is going to be to identify the counterfactual using a running variable that's going to allow us to separate treated and untreated areas. So that's basically the running variable is the one that generates this discontinuity, no? So one alternative that we have is the use, for example, the Oueme River that you can see at the top of the map. So you can identify using the Oueme River, we can identify or compare areas on one side or the other one of the river. And we can see, for example, in orange, the areas of the intervention. And another option could be, for example, using based on Jones et al., for example, there is a paper in which they identify what they call common area, in which areas that were exposed to irrigation, the irrigation areas basically were there, and they managed to identify areas that were close to these common areas, but they were offsite and they were not affected by these irrigation waterworks. No, another alternative is to based on Ali et al. So you have imagine that you have the center, the construction of the waterwork. And idea is to identify areas in, like I construct like inside band and compare with the areas outside band. So this is like the treatment inside, and the areas outside are going to be the control areas. That could be like another alternative. Also, we plan that another alternative that we have is to use difference in discontinuities, in which we are going to be basically it's like an RDD plus combined with a different diff. So it's always the idea of how we are going to be able to identify to use like a cutoff to identify the contrafactual, the treated and contrafactual areas, no? And also this relies on the parallel trends assumptions. And you can see in the maps, in the graphs here and in the maps, on the lilacs, for example, the idea in this particular paper of Gara and Chenoy in 2021 was to compare the lilacs using a particular border, no? From one side on another one, you can see how the differences were similar before the intervention, and once there was this particular intervention that they used there, you see a change in terms of night light, no? Other alternative that we have, for example, is to, as I mentioned before, using machine learning algorithm to identify the contrafactual areas. And we have, for example, also the supporting vector machine algorithm that was used by Ana Paula in another paper. And now I'm going to move on to the plots georeferencing. So we were talking before about the infrastructure, and now we are going to talk mostly about the social economical impact evaluation. So now this is basically the research question is mostly about the farming first school. No, this is another intervention, but it's also part of the same project. So the idea is to see this farming first school, they increase, for example, contribute to these climate resilient technologies, contribute to welfare gains among vulnerable farmers. There is also the idea of if these gender sensitive approaches have an effect in terms of increase women's agricultural decision making, for example. There is also about the idea about if these particular collective learning strategies, they induce change on farmer beliefs and practices. So we have a very nice battery of indicators that we managed to, for which we have a baseline, we collect data at the baseline level last year. So we have information in terms of food security, in terms of agricultural decision making, for example, perception of climate change impacts. And the idea is going to be to expand this part and include some particular geospatial indicators on a subsample of plots from the sample that we collected data last year. No, so this is mostly how it looks. The farming first school strategy. So we have the mixed, we have the mixed farming first school, the Village Saving Loans Association, this complementary, and the female-only farming first school. And then we have the female and male controls, in which there are only farmers that are male or farmers that are female. There is also the farming business school. So how did we identify this contrafactual group? So we rely on we do like a geospatial propensity score matching. So basically we use information at the village level. We construct geospatial indicators for this particular village and use the propensity score matching to identify areas that were similar to the treated ones, no? That was at the first level. And in the second level, we did like a listing exercise to identify households that share similar characteristics that we use during the selection criteria in the for the treatment area, no? So we use, for example, the selection criteria that we use to identify the farmers in the treated areas where, for example, they were not from the producing every crop, for example, there were small farmers, and they didn't receive farming first school intervention in the past. Doing that, we managed to get a sample of 1,000 treatment and 1,000 control. So the idea is going to be simple to make. You can make a nice comparison using the T1 plus T2 versus C1 plus C2, and then we can also make a comparison with T3, T3 versus C2 to capture the effect of female-only farm and first school versus female control, while other particular comparison could be possible, but for this particular project, they're going to be underpowered, unfortunately for that. What we are planning, I'm very close to finish here. We have the total sample of 2,700 plots that were in which we collected information, but we didn't have the information of coordinates, for example. So the idea now is to make a random selection of a subsample of the 800 plots, and we have around 400 treatment and 400 control. They were identified using a simple random sample without replacement. And they are representative in terms of the treatment areas, in terms of the Oueme area. Also, we put particular attention of choosing or identifying plots that were producing the main perennial crops and annual crops, because this was one of the main focus of the projects. And we also tried to remove plots that were too far, but not too close to, thanks to another recommendation that we have from Kenneth that is here. The idea is going to be to double measure based on what we discussed during these days, to measure 2 times the same plot. One part is by using smartphones, and I use a mobile topographer app. And the second part is going to be you measure again the same plot, but using the GPS device. No, so yeah. So now the idea that we have now is just to compare treatment versus control areas using the similar framework that you use for the socioeconomic impact evaluation. Other particular option is just to assess the effects inside the plot. For example, if there is a particular effect, the effects are contained inside the plots, or maybe on the borders from, for example, 10 to 100 meters. We can also try to identify like catchment areas using the water words. So what is the catchment area of the water words that are going to be implemented, and then try to see if there is the plots in which we have the sample, they were affected or not by these particular water words. That's kind of additional thing that we thought that we could do. Also to complement, we have the demonstration plots. So plots in which the farmer first school were going basically to the school to receive this intervention. And we are trying to measure also a subsample of these demonstration plots in the impact evaluation areas. An idea is going to be to see if they are implementing the same type of agricultural practices that we're going they're receiving in demonstration plots. And then we are going to the plots of the farmer to see, we can compare, they have similar characteristics, they have similar agricultural practices in place. So this is mostly what we have right now. Yeah, I think that's all for now. I'm happy to hear the comments. I mean, this is a work in progress, so any comment is more than welcome. Thank you.
Thank you. Thanks so much. Any questions for Luis? Any recommendations? Susumu?
Okay, thank you. Thank you for the presentation. I think it was a lot to digest, so I'm not sure if I followed very well, but I think your overall question was whether the infrastructure plus land restoration intervention increased the climate resilience, right? So how do you define, or like what is the main indicators to see the climate resilience?
Thanks. I think, yeah, that's a good point. I mean, the idea that we have right now is to use not exactly, it's going to be like a climate resilient, because climate resilient, if we talk about just resilient, is another concept, no? So probably where we are trying to see if there are some parts that are related with climate resilience. For example, that you see there is an increase in terms of tree density, in terms of the greenness of using, for example, an NDVI. Maybe we can use something that they mentioned today, no? The one that Simone, that is LST, for example, there is the increase on moisture. That kind of things probably are related with the climate resilience, but maybe we want to go to have the concept of climate resilience. Yeah, that's a good point, and probably something that we should explore further. I mean, it's not only probably for this particular project, but also for the ones that are related with the global climate fund, no? Because it's like a broader part, and probably we could think about something else that we could explore and to capture climate resilience, no? Yeah, in the long term, yeah.
For promotion purpose, it's not the global climate fund, but the green climate fund.
The green climate fund.
Yes.
Yeah, thanks.
Thank you for that. Is it on? Thanks for that presentation. Sort of building on that question, I'm wondering, because I had the same thought, and you'll get at the climate adaptation and resilience as like an ultimate impact outcome through the counterfactual, but only if you also are bringing in actual climate information. And so I'm curious if you would consider like overlaying some other indicators for temperature or precipitation along with any differences that you're seeing in performance between the treated and the control locations.
Yeah, I think that's a good point. I mean, probably we can explore something like that. I mean, I was thinking also when I saw Simone's presentation, we could integrate this LST, for example, to capture a little bit the temperature. That would be nice to explore also, no? Yeah, but I mean that maybe I didn't have time to mention is most about this farming first escuela list. This part of intervention is going to allow us to see the socioeconomic impact evaluation of the project, no? And the idea is to now we are going to the field to measure the plots and try to complement and capture things that we cannot capture through socioeconomical part, no? So the idea is just to complement both parts. We can have, for example, food security indicators from the socioeconomic part, and then we can see how they're related with the particular yields. We can also have measures of agricultural production and yields from the socioeconomic part, and then we can try to see what else can we capture through alternative measure proxies of yields, no? So the idea is always to complement this part, no? Yeah, thanks.
Well, last but not least, we can have the fourth presentation, please.
Can you hear me? Okay, so this is basically the sister presentation of the previous presentation because it's all about the same portfolio of a project with the with the Green Climate Fund. So this is a project in Bolivia. Well, I'm Silvio Daidone. I'm an economist. I've been working for the Office of Evaluation now for about 2.5 years. And basically, I am overseeing the evaluations, not just the impact, but broadly speaking, the evaluations of this big package of projects that we have. The GCF is the second donor of FAO at the moment. Then we have the GEF. So this is quite a quite important area of work for us. And again, it's a sister presentation also because this is purely work in progress. We are foreseen to go on the field later during the fall. But just to give you, this is an old version. Sorry. I have revised all the presentation. I've changed completely. All right. That's the old one. I have uploaded this morning. Yeah.
Can we try to have the other version of the presentation, if that's possible?
But in the meantime, the first slide is very similar. All right. If you can upload the other one, please. Okay. So basically, this targets the Macrovalles region in Bolivia. We have 5 departments, Cochabamba, Santa Cruz, Chiquisaca, Tarija, and Potosí. There are various conditions, very heterogeneous areas. So we go from dry areas of the altiplanes of Cochabamba to the hot altiplane of Santa Cruz and Tarija, where we have hails, which is one of the most recurrent shocks. All right. It's a big project funded by the GCF, which contribute through a direct grant for 33 million. Overall, the project is $63 million, and aims to reach 81,000 beneficiaries. This is the definition of beneficiary. This is something that we're working a lot with the GCF because it's not just only those that directly receive the project, but it's the household as a whole. So when you will see later the type of intervention, the technologies that we are promoting with the country office, you will see that the numbers simply do not adapt to what you will see there. But this is because of the definition of beneficiaries. And the objective of this project is to increase the resilience to the climate change. So again, reference to this almost mythological word, resilience, for the farmers and the communities in the valleys macro region. So. All right. So, like any GCF project, we have an institutional component. So which is component 4 here, which aim to improve what we call the enabling environment. So legal framework, enhancing capacities at the institutional level. We are tackling this in the evaluation, mostly with qualitative methods of analysis. But obviously, for the purpose of this presentation, we will look at the first 3 components. The first 2 looks at targets, households, and community. The third one, the macro watershed level. All right. The third one, for the macro watershed, it's about restoration of macro watershed and ecosystem function services. So basically, it's about reforestation, tree planting, like for the Benin case, about tree planting, strengthening the degraded ecosystem, the degraded land, especially the native species, because you will see, I've been on a mission the last year to Bolivia for discussing the impact evaluation approach. So you will see beautiful pines or eucalyptus in the middle of these altiplanes, which is quite weird, right? So one of the objectives to restore these degraded lands is to go back to the native species. Okay, and the first 2 components instead works with the household and the communities. The first one is about basic trainings and the distribution of inputs that aims to improve productivity of the land, and adoption of climate-smart agriculture and agroforestry models. And the second component is about technified irrigation, especially drip irrigation. So these are the technologies that I'm talking about: anti-hail nets, thermal blanket, solar tents. Then we have also hydrogel that is used both for component 1 and component 3 of the project. So also for strengthening the growth, the tree growth. We have training, as I said, in conservation practice in agroforestry. And for component 2, we have community water reservoir, atajados, in the Bolivian case, which are covered with geomembrane, which is probably the most costly intervention made by the project. The water reservoir are already built by the municipalities, not by the project itself. And then we have the irrigation kits, which are normally around 0.25, 0.3 hectares of land per beneficiary. So we are not covering full parcels, full plots. Okay. So this is the well, if you could, okay. This is a little bit the empirical strategy for the first 2 components. We aim to do a randomized control trial where we have a multi-treatment arms design. And treatment 1 is about providing the geomembrane reservoirs and the inputs, which are the irrigation kits and the technologies, the protective technologies that you've seen before. In the second treatment arm, we have the inputs plus the training. Both treatment 1 and treatment 2 are supposed to receive the package after the baseline survey. And then we have the control communities that are the waitlisted communities, so that will enter into the treatment 2 years after the program has started. So obviously, for this to succeed, we need that the control communities do not receive the intervention in 2 years. And you well know that sometimes it's a challenge. Why? Because you can imagine you do some sensitization with the local communities. You discuss that there will be a project sometime soon, so that there is really a tension for communities to enter. So waiting for 2 years might be a challenge. All right. So actually, during the process of the cluster formation, what we call here PICS, which is Planes de Intervenciones Comunitarias, community intervention plans, communities want to start, want to engage. So entering into the project, waiting for 2 years is an issue. Okay. But also this depends about the project funds. So as you, I don't know if you know, but the GCF does not disperse all the resources all at once. So this is conditional on implementation targets that are reached. So if they have basically dispersed, I don't remember whether 70% of the first allocation, then they will receive the second, and so forth. Okay. Then we need obviously a sufficient number of communities per each treatment arm to have an adequately powered studies. And then all these peaks, all these clusters need to be comparable in their agroecological characteristics, and the project needs that have been expressed, manifested by the community themselves. So for instance, not in all communities we have water reservoirs, okay? So comparing communities in T1 and T2, if there is no water reservoir, is probably not the ideal case. So what we are doing now is waiting for the country office to finalize the PICS formation, the cluster formation, and select all those communities that are comparable from the agroecological perspective, and by the selection of the inputs and the kind of activities that we would like to develop during the project. Okay, so what we are doing, for instance, in each region, we are planning to do triplets, and then within the triplets extract randomly the community that will be in either T2, T1, or in the C group. Okay, so this is basically the idea of the study. No, this is not what I wanted to show, but anyway, I will show here, and I will go by Capella because it's all different. All right. So in terms of the analysis, we will have a baseline survey that is planned for 2026, and a follow-up survey that is planned for 2028. Obviously, contingent all the peaks formation that is conducted by the country office for the targeting. So we are still at the targeting phase. Now, what we are planning to do in terms of the after the randomization is conducted, we will have analysis at the household level for the socioeconomic data that we have discussed before. So integrating the socioeconomic data with the Earth observation. How Earth observation fits into this discussion? Well, first of all, what we are planning to do is to conduct drawing polygons. Okay, how? Because you perfectly know that the direct GPS measurement, it's a bit expensive, especially in these communities where you can find a parcel, a plot of land that is 8 to 10 kilometers farther away from the main central area of the communities. So what we are planning to do is something like a mixed approach. So while we implement the baseline survey, we will draw polygons, plots with the help of the respondents. Okay. This is something that we have observed. There are 2 or 3 studies in the literature. The ideal scenario would be to run a small experiment where we combine the direct GPS measurement, maybe thanks to the support of the monitoring team that we have in the country office. So obviously for a small sample of the parcels that we have. Now, the main issue that we will face here for measuring the outcomes of interest for component 1 is productivity, because productivity is one of the main indicators in the log frame, and especially potato productivity. Why potato? Because this is the commodity, the good that the country office has selected, because it's very relevant in terms of own consumption. We are talking about subsistence farmers, we have to remind, but also for engagement with markets. Okay, so apparently the quality of the seeds, the seeds variety that they have selected, it's particularly good for French fries. All right, so they have selected this specific potato variety for improving to strengthen the income generation, especially during the dry season in the winter. Okay. So what kind of Earth observation data can we use in that situation? Because we have heard very well from today's presentation, yesterday presentations, that NDVI maybe cannot be the most adequate indicator for productivity measurement. Okay, so suggestions. We have seen that there is a systematic review of the literature on NDVI measurement for potato harvesting. And in terms of also of the time for which the remote sensing data could be extracted. So in a nutshell, between 35 to 50 days after planting. That's the good timing. So, just finished? Okay, well. The second, well, it will be quick. The second type of indicator that we are looking is for component 2. It's water crop productivity, which is basically based on evapotranspiration. So combining the yields that we will measure from the first component with evapotranspiration, this is an indicator which is quite used in the literature. While for the third component, obviously, as we have said before in the previous presentation, we cannot think about measuring biodiversity recovery or water recharge because these are indicators that you might observe after 15, 10, 20 years, not during the time span of the project. So this is very relevant and related to what Lorenzo was presenting before. But maybe something related to moisture, vegetation, survival of the plants. These are all indicators that through the indicators that we have through Earth observation, we can quietly include in our logical framework. Now, there was also a slide on the relationship between monitoring and evaluation, but basically the nutshell is that the relationship with the country office is fundamental. In this specific case, we have found a terrific M&E officer, terrific, that has been really helpful, not normal to have somebody so helpful, to have a randomized control trial, pushing also with the technical team, because the technical team, obviously, as you can imagine, wants to go and support the communities immediately, which is fine, obviously, but from an evaluation perspective, this has some drawbacks. So this is key. We are trying to expand to the broader portfolio of the GCF. So we are collaborating with Ana Paula and Nick's team with Benin and with Malawi as well, but we have all the RED Plus intervention, Colombia, Argentina, Papua New Guinea, all the new funded activities that are waiting for our evaluation, where in the absence of direct household survey data, we will have a geospatial component. I mean, it's mandatory. I'm sorry for the presentation.
Thanks so much, Silvio. Sorry, apologies. That your complete presentation couldn't be shown, but happy to circulate it so that whomever is interested to learn more about this project can look at the design and the ideas. So as you can see, this is a lot of work in progress. It is really, I mean, I think the contrast between what has been presented today in terms of evaluations and in the past few days is really the context in which we are operating, no? And I wanted to highlight that because I think especially these two presentations highlight, first of all, projects funded by the Green Climate Fund that are quite heterogeneous in terms of components. So there's always an institutional component. There is a community level component. There's a geospatial component. So, and not necessarily these components are implemented at the same time. So for example, in Benin, the infrastructure work, which is one of the components that we want to evaluate, is still at the phase of approvals, because this is large infrastructures that, you know, are managed by the government, need to be approved. Also, there's a lot of interest, of course, in this building of infrastructures, as you can imagine. So it takes a long time. And so by the time the project ends, it's very difficult to start evaluating. So going back to what Lorenzo is saying, so note for the donors in the room or those working in GCF is that I think we have to lower our expectations of what we can actually measure in the context of the project itself, no? Because the evaluations are always embedded inside the timing of the projects, and we need more time to evaluate at the end of the day what has been done in the project. So I think that's one, for me at least, is the one key message that it's coming from the discussion today. We're trying to work on longer term tools that we can use. So for example, if we are doing the investment of collecting plot level data in Bolivia and Benin, we can go back to that in hopefully not in 10 years time, because we don't know